First of all, I want to welcome everyone to our first grade enhancement math practice. In this video, I will go over week 1 problems. Let's first look at problem number 1 in day 1. This is a simple regular math question. Here we have a sequence of letters, some A, some B, some C, some D. We just need to count how many each has. All right, so let's count it. Say for A, let's look at A first. All right, so we have 1, 2, 3, 4, 5. So the number of A is 5. Let's do B. For B, we have 1, 2, 3. So here, the only thing is make sure you do not miss any letter. All right, okay, so let's continue counting B. 1, 2, 3, 4, 5, 6, 7. Okay, so the number of B is 7. So, okay, so we have B is 7. Now let's look at C. So we have C. So 1, 2, 3, 4, 5, 6, 7. All right, so C is also 7. Finally, let's count D. All right, so we have the D is 1, 2, 3, 4, 5, 6, 7. All right, so the number of B is also 7. For this example, B, C, D has the same numbers. A is different. There are 5 A's. Okay, problem number 2. This is also a regular math question. Here we have 4 pictures. Each picture has a certain number of animals. What we need to do is to find out that picture that has most animals. All right, all we need to do is just count one by one. For the first picture, you see it has fish. How many do we have? 1, 2, 3, 4. Okay, so we have 4 fish. The second one, here we have several cats. How many? 1, 2, 3, 4, 5, 6. Okay, so we have 6 cats in the second picture. Picture number 3. All right, so picture number 3, here we have rabbits. How many? 1, 2, 3, 4, 5. All right, so there are 5. Therefore, the middle one has the largest number of animals, which is 6. All right, now let's move to Math Olympia type questions. Problem number 3. The problem says, at the beginning, we have 3 cups of water. So the cups are the same and the amount of water is also the same. So this you can see, they have the same water level. And then in each cup, we add certain number of stones. And we know, while given water, if you add a stone, the water level will go up. Obviously, the more stone you add into the cup, the more water level will go up. Therefore, the question asks, for the question, which cup has the largest number of marbles? Because we know the more marbles in the cup, the more water level will be raised. All we need to do is to compare water level to see which water level is the highest, right? Now, when we compare the water level, you see this one is right here, and this is right here, and this is here. Obviously, this one has the highest water level, right? So this one has the highest water level, and which means this one has the largest number of marbles. Question number 4. This is also a Math Olympia problem. What do we have here? Okay, so we have 4 fruits: apple, peach, pear, orange. At first, we don't know which one is heavier than which, but we have the following 4 pictures. Right? In each picture, basically, we are comparing 2 fruits. Like for the first one, what we compare is pear and the peach, because the pear goes down and the peach goes up, and obviously means the pear is heavier. And similarly, so here means apple is heavier, and this means orange is heavier, and this means pear is heavier than the orange. Now we need to order them from the lightest to the heaviest, right? So this is what we need to do. So we need to order them from lightest to the heaviest. So basically you have a puzzle. You can just play around, right? Solve the puzzle. Now you can choose, have 4 pictures. You can choose whichever picture you want to start with. Say, I choose this one to start with. So this one tells me that orange is heavier than apple. Okay, so when from this picture, I can get the orange is heavier. So we can, because this direction we go from, we order them from lightest to the heaviest. Okay, so then we have, this is apple and this is orange. Okay, and then let's look at orange. This one, this picture tells me orange is lighter than pear because pear goes down. All right, so then I know the pear is after orange. And then we look at this picture. It says the peach. If you compare peach and apple, because apple goes down, so that means apple is heavier than peach. All right, so from this picture, I will get, okay, I should put peach in front of apple. Okay, so then we get the order. Peach is lighter than apple. Apple is lighter than orange, and orange is lighter than pear. So it's peach, apple, orange, pear. For the first one, we don't really need it because the other 3 pictures are enough to give us the correct ordering. Problem number 1 in day 2 assignment. The problem says, Jack brought a box of mooncakes to share with the 6 friends. Each one had 1 mooncake. And the question asks, then how many mooncakes are in the box? At first, you might think, oh, because there are 6 friends and each one got 1, so there should be 6 mooncakes in the box. Well, that's not really correct because you forget a Jack. It says Jack share with his 6 friends. So what we have is Jack plus his 6 friends. 1, 2, 3, 4, 5, 6. So 6 add 1, which in total here is 7 people. So in total, 7 people are sharing this box of mooncake. Therefore, the answer is 7. Question number 2. Here we have 4 pictures. Each picture has a certain number of items. Say the first one, we have star, and then we have this like a moon. He has watermelon, and this one has flowers. The question asks, we need to identify the picture that are different number of items. All right, so let's count them. Here, how many we have? 1, 2, 3, 4, 5. So it's 5 stars. 1, 2, 3, 4, 5, 5 moons. And 1, 2, 3, 4, 5 pieces of watermelon. And he has 1, 2, 3, 4, 5, 6. For this one, it has 6 flowers that is different from the other 3 pictures. So the answer is the flower picture. Question number 3. This is a Math Olympia question. The problem says we have 2 turtles, turtle A and turtle B. Now, turtle A goes around, cross along the red path. So the goal is first go to right, then go up, go to right, go down, right, right, and eventually arrives at the opposite side. And turtle B starts at the same time. It goes along this blue path. So we see goes right, goes right, goes right, up, right, and eventually again also arrives at the opposite side. The question asks, which one arrived first? Now you see, in this problem, we assume both turtles, they crawl with equal speed. What does that mean? That means within the same amount of time, they crawl the same distance. That would mean they will go with the same speed, that they're equally fast, always say. Okay, well, this says if we want to find who arrived first, we just need to find which path is shorter. So this is okay. So who will arrive first? This just means which path is shorter. How we find which path is shorter? Here, the one sentence, the problem says all small line segments have the same length. So what are the line segments? Right? So this is line segment. Let me use. So here we have, this is line segment. This is line segment, and these are the all line segments, right? Small line segment. We assume they have the same length. And if you look at each path, the path of the red one and the blue one, they all consist of small line segments. So, all right, so then we just need to say, okay, if you want to find which one is longer, which one is shorter, you just need to count the number of line segments, right? So, okay, so we just need to count number of line segments. Let's count them. So here we have 1, 2, 3, 4, 5, 6. All right, don't forget. So here we have 2, right? So 1, 6, 7, 8, 9, 10, 11, 12, 13. All right, so for this one, we have 13. For the red one, it's 13 line segments. Okay, how about the blue one? 1, 2, 3, 4, 5, 6, 7. All right, so here you see we have 2 line segments, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so the number is 12. Okay, so this 12 is smaller than 13. Okay, so then we get this one is shorter. Okay, therefore, we can say B will arrive at the opposite first. Question number 4. Here we have 2 squares, square 1 and square 2. And then we point A is the middle point, B is in the middle, C is in the middle, D is in the middle, E is in the middle, and F is also in the middle. All right, so this gives us 2 red parts. And the question is, which one is larger, or are they equal? When you first look at this, it's not so clear, right? For this one, we clearly know this red part, because it's in the middle, is half of it. That's for the picture 2. But for picture 1, it's not so obvious whether this is half of it or not, right? Okay, so what we're going to use is something called cut and paste. So pretend, right? So pretend we have a scissor and we are going to cut one picture and we are going to, just like we are playing with the puzzle, and we are going to rearrange it. This is a very useful trick in geometry, okay? All right, so let's do it. I'm going to cut it, right? So let's look at picture 1. I'm going to cut it. So pretend I have a scissor and I cut it in the middle and then vertically. So this, by this, I cut this one into 4 triangles, and they are equal, right? So they are identical triangles. Now, okay, so let's say pretend I already cut it. Now I'm going to rearrange it. So the way I do is I'm going to move this part to the top. Right? Okay, so let's say I removed this part, so it's gone. This part is gone, and it goes to the top. Right? And similarly, I'm going to move this one to the top, right? So the right lower one triangle to the top, right? So it's gone. So this part is gone. I remove it. And it goes to the top. All the things are equal. You see, this one and this one, they are equal. So that's why I can do it, because everything is in the middle, right? And by doing this, you say, oh, wow, okay, great. Basically, by rearranging things, I have transferred the first one into the second one. This means they have equal size, right? The size is equal. Both of them are half of the whole thing. So they have equal size. So the thing I'm doing here is called cut and paste. Problem number 1 in day 3. So this is a simple question. Here we have 5 flags. We need to order them from the shortest to the longest. All right, I will just use number 1 to represent the shortest and then go up all the way to 5, the longest. Well, look at these 5 flags. Obviously, this guy is the shortest. And then we examine the others, and this one is the second shortest. And this is in the middle. This one is the second longest, and this one, the one on the right, this is the longest. So this is how we rank them. Question number 2. This is also a regular math question. So here we have 1, 2, 3, 4, 5, 6, 7. We have 7 animals. The first one asks if we count from the left. So here is left, and here is right. If we count from the left, which animal is on the 5th position? So if I count from the left, so this is 1, 2, 3, 4, 5. So cat is on the 5th position if we count from the left. Now, if we how about from the right? Okay, so if we count from right, let me put right on the bottom. If we count from right, okay, so then this one, which one will be on the 5th position? Then we have 1, 2, 3, 4, and 5. So if we count from the right, the one on the 5th position is seal. So seal is on the 5th position. And then you say, hey, then question 3 asks, which animal has the same position number? You go from left, you go from right. And then if we look at what I put here, we see, wow, it's the crab, the one that is right in the middle, because its position is 4 from left and also 4 from the right. Question number 3. This is a math Olympia type question. Here says we have 2 cups of coffee without water and without sugar, but the number of coffee, the amount of coffee is different. And then we add 2 cubic sugar into each cup. The size of sugar is the same. The question is, which one is sweeter? Now, intuitively, it's kind of clear, right? If the sugar is the same, then the less water we have, it will be sweeter. You think of that. Say you are drinking juice, or you are drinking, you are having soup. If the juice is if you think the juice is too sweet, what do? You just add more water, right? It will dilute the sugar and make it less sweet. Say if you have a soup and you find it too salty, what do? Again, you just add more water to dilute the salt. All right, so the thing is, I hope this is able to convince you, if the amount of sugar is the same, the more water we add to it, the less it is sweet. Okay, and then we say, okay, so we want one is sweeter. That means the one that with less water. Okay, so it's the one on the right. Question number 4. Fill the minion makes several movements. First, turn right, then turn back, and then turn to the left. Now, after the 3 movements, in order to go back to his original position, what shall he do? Now, the most convenient way to do this is, let's do an experiment. So here I have this stuffed animal. It's facing you. So this is the right-hand side. I put a clip here. So this means the right-hand side. Let's do the movement. Okay, so first, this is the right. So this is right, this is the left. Right. So with this clip here, so this is the left, right. So first, turn right and turn right. And then turns the back. Okay, so then turns to the back. and then turn left. Remember this one is, this is the right, this left, then turns left. Now it is facing me, okay? After the 3 movements. In order, now we need to go back to the original position that's facing you. How should you do? It needs to turn to the back. Okay, let's repeat it. So it starts from the original position that is facing you, and then this is the right hand. Turns to right, and then turns back, to the back, and then to left. This is right, this is left, then turn to left. Now, how to go back? Turn all the way to back. So the answer is turns to back. Day 4, question number 1. This is a simple puzzle question. In the middle, we have a strawberry, and then it says draw a square on the left of the strawberry. So this is the left, and then on the left, and then draw a diamond on the right. This is the right. And then draw a circle above the strawberry. So I draw a circle here. Finally, draw a triangle below the strawberry. And this finish the puzzle. Question number 2. Question number 2 is from a past math kangaroo computation. Here we have a puzzle. The puzzle has 4 different figures, which are basically 4 symbols of a standard playing cards. We need to figure out which one. So here we have 5 choices, right? A, B, C, D, E. Which one will fit the missing center? What do we do? Well, there are different ways to do this problem. One way is you say, okay, I just check, right? Just check each one and to try to rotate to see whether it will fit the missing center. Now, a more efficient way to do is let's try to draw the missing center and to compare the A, B, C, D choice. Now let's draw it. Well, for convenience, I use red card to draw it. So it's half of this one. It's like a leaf. And then half of this. And then half of this. And then half of heart. Okay, now when you compare, say, well, if I look at what we have here, which one is the one that we need to find out? In particular, you see, we have only one, let's call this flower, right? So let's say this flower. So we have only one flower, we just need one flower. And then see, okay, do we have a flower here? No, there's no flower, there's no flower, there's no flower to gone. But here, B has flower, but it's 2 flowers. There are too many, we just need exactly one. And then we can, oh, this one has exactly 1 flower. So C is the only one that might work. Let's see, is it? Yes, because for C, how can we go use C? How can we go to use C to fill the center? What we do is we just rotate it, right? So this is the PC, you just rotate it. And this one will go to right here. And then you see this one will go to right here. And this go to here, and this one goes to there. You rotate, and then you move to it. So the answer is C. Question number 3. This is, again, is a math Olympia type question. Here we have a bunch of happy face. Also, we have the square and the circle. The question is, the first question, how many happy faces are inside the circle? All right, so let's draw the circles. The circle is right here, right? So this is the circle. And we just counted 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5, 6, 7. The answer is 7. Now, the second question, how many happy faces are inside the square? All right, so let's draw the square. So this is the square. So how many of the inside squares? 1, 2, 3, 4, 5, 6, 7. Again, is 7. The third question, how many faces are inside both the circle and the square? Now you understand both means it should be inside both of them, inside the circle and inside the square. When we look at the picture, we say, oh, obviously we have these two. They are both in the square and in the cycle. So that's 2. Now the last question, how many faces are inside the circle or the square? Some of you might have problem understanding this sentence. This sentence basically means we have happy face. You can just collect, it just means we collect all of them. Could it be in the circle, in the square, or both, whatever. We just collect all of them. That means all, okay? All right, so if we collect all of them, you just get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So total is 12. So this just means it's 12. Some of you might at first might get, oh, I have 7, 7. And if you know how to do addition, you might think it's 7 plus 7 is 14, but it's not 14. Why is not 14? That's because they have overlap. If you do 14, these two guys will be counted twice. Okay, so instead of 14, what do we have? 12. So you could just count directly, 12. Okay. All right, question number 4. Here, well, 12 animals line up. When counting from the left, the mouse is on the 5th position. If we count on the right, the ox is on the 4th position. The question is, okay, so how many animals are between the mouse and the ox? Let's see. We count from the left, right? So count from the left. The mouse is on the 5th position. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And then we count from the right. The ox is on the 4th position, the left, and then we do right. Okay, so the 4th position, 1, 2, 3, 4. So it's 1, 2, 3, 4. All right, how many do we have so far? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9. All right, so we already have 9 animals. But in total, how we have? We have 12. So that's how 12. Okay, so we need to go from 9 to 12. How many do we add? 9, 10, 11, 12. So we add 3 more to go from 9 to 12. 10, 11, 12. So the answer is 3. So there are 3 animals between the mouse and the ox. A5, question number 1. Here we have a map. The map is Hercules, the journey of Hercules to find the golden apple tree. So first Hercules goes to the lion, and then to the dragon, to the snake, and finally goes to the golden apple tree. What we need to do is to identify the direction. See here we have a direction map. This is east, west, north, and south. So if we compare to this map, you see first it goes to the east, the direction. So here we circle east to the lion. And then from lion goes down to the dragon, which goes to the south. So we circle the south to the dragon. And then east again, from the dragon east to the snake. We circle the east, and then north to the golden apple tree. We circle N, means north. Problem number 2. Here we have 5 flower pots that are labeled 1, 2, 3, 4, 5. And then we also have flowers that are labeled 2, 4, 3, 5, 1. Now, what we need to do is to connect the flower pot with the flower that they have the same number. So this is 1. So we go with 1. And here is 2. We go with 2. So this 2 and 3 go with 3. 4 go with 4, and 5 goes with 5. Question number 3. So this is a Math Olympia type question. Here we'll figure that is made from cubes. The question is, how many cubes are used here? When you look at this, when you count this, you say, oh, well, this is 1, 2, 3, 4, and 5, right? So this is one that is on the back, and we can see one corner. 6, you say, oh, well, 6. Well, here the tricky part is, it's not a 6, it's 7. You say, hey, why 6 instead of, why is 7 instead of 6? What is the actual one? The actual one is the one that is right below it. You cannot see it because it's surrounded by other cubes. Okay, we can actually draw it, right? So if I remove this, remove these two, what we have is right here. We have 4 cubes. And then we have a cube on the front. And we have a cube on the back. And then the top one, this is the top one. Top one is right here. So what happens is we move this front one to here, and that's what happened. And then we move the back one to here, and that's what is connected here. And then we move the top one on top of this cube. That is the one that I use red. That is the one that is not visible. So we have is 1, 2, 3, 4, 5, 6, 7. So we need 7 cubes to build this figure. So the point is there's one that is not visible because it's surrounded. But after we remove the front, the top, after we remove the front, you will see. Yeah, if we remove the top one, you will see it's right here. So that's what we need to do to construct it. Question number 3. All right, so here we have to put 1 to 9 the numbers into here. This is a puzzle. All right, so here we have 5 rules. Let's do one by one. So 6 is in the middle. So this is 6. 3 is on the right of 6. So 3 is right here. And 3 is right below 5. Okay, so 3 is right below 5, so which means 5 is right above it, so right below it. And 8 is right below 3. So 8 is right below 3. And it's on the right of 2. So 8 is on the right of 2. So 2 is here. So it's on the right of 2. And 7 is on the left of 6. But it's right above 9. It's right above 9. So 9 is here. And 4 is right above 7. Okay. Now what is this? It's 1 because 1 is missing. So 1 is right here. And that's how we put these 9 numbers according to 1, 2, 3, 4, 5 given rules.